Let's go ahead and get started. Everybody's been scanned. The audit trail's starting. My name is Scott Henninger. I'm a senior consultant at MarkLogic. Been here about 1.5 years. How many of you, is this your first time at MarkLogic? Oh, not as many. Well, I'm one of those first timers too, so I figured, you know, if I'm gonna get wet, I might as well jump in. So I'm gonna talk a little bit about why my slide screen proceeded. I guess maybe that thing's finally working for him. Before working at MarkLogic, I worked for Top Quadrant. We did semantic technology work, so you'll see a little bit of that bit behind what I talk about as we go along here. So I have a very strong semantics background, and coming to one of my efforts, they came in and said, well, VP dropped a bomb on us. He told us we should start using PROV-O. And I was a week into it. I said, well, I think I can help you there. And the product is really ready to help you there as well. So that was kind of the genesis of this slide set. But it's much broader as well. Stellian will be giving this talk in London. And he actually gets credit for a lot of the slides that you'll see. So it's been a collaborative effort. And there's a lot of people very interested in, a lot of our customers very interested in provenance, lineage, audit trails, et cetera. I'll talk a little bit about some distinctions between those. We'll start this out by kind of looking at 3 different dimensions of provenance. I'll talk a little bit about the data governance aspect of things. I'll get into a little bit of light modeling. We'll actually get into some of the details, but we won't get into it too heavily. And then talk a little bit about usage and how you manage provenance data. So, that went 2 ahead, so I'll have to keep an eye on this guy. Data governance. How many are actively involved in data governance projects? How many of you be looking for a data governance project, be doing that within the next year, and you can raise your hand for both? So there's quite a bit of work in here. So data governance is something that's been around for a while. Basically, what's really gone on here is that data in organizations has become so large. Is it continuing to do that? Okay. Maybe it's timing me. So I'll go faster. The overall sort of thing behind this strategy and execution is, yeah, you want all these things to be current, reliable, accurate, et cetera. But it becomes more and more difficult as you get more data from different sources, different places. And basically, data governance is all about those policies you have to start putting in place, those layers on top of the technical, and the technical is going to have to actually start implementing as you go along. So data governance has really become one of those things that are either desired or absolutely necessary, depending on where you are, what industry you're in. And one of the other issues with data governance is that you don't just get data from one source most times, and or that data often gets transformed and moved in sort of an ETL fashion or just a transform fashion as you go along. And so you're creating and deriving information, you're analyzing that data, which creates more data, you're reporting on that data, and the report is yet more data. And all of these things basically come through a bit of a pipeline, and we're kind of pointing out that it's kind of interesting that MarkLogic has shown for ingest, prepare, transform, publish, but not delete. Although you should quibble with deletes, retirement would be a better word, right? And data doesn't go away. I used to work for storage technology, and this is 20 years ago. We did those big silos with the little robot thing that went in and got all that data. Huge amounts of data that people have out there. It never really goes away. Provenance metadata. Now what we're really getting into here with the provenance part of it is that we're really saying that you have your data. Your data for MarkLogic is going to be in documents, JSON, XML, et cetera. Now we're going to start getting data about that data. It's a true metadata sort of scenario. Data about the data. That data happens to be about where this data has come from, et cetera. I'll get into definitions in a minute. So it really gets into the origin, the timeline of when that data has changed, the process by which those things have changed. And I kind of like this word cloud, and here it is timing me. That basically, each one of these is by itself a topic that's of immense complexity and immense consequence to a lot of organizations. Now, I've put up some definitions here, which came a little early, but that's okay. It's going to happen to me in a moment here, but we'll deal with it as we go along here. And I don't mean these to be, absolute definitions. What I really want to do is point out some distinctions. And I'll start from the bottom with audit trails. So what that's really about is making sure that as your data changes, you're able to go back to a particular point in time and say, what was the data's at that point in time? And or you can just say how that data has transformed. You might have versions, you might have all sorts of things with it, but it's all about how that data has changed over time. Lineage includes getting into the actual origins of the data. Where does this data come from? And how is it going to move over time? How has it been moved over time? What has moved it over time? Actually, Provenance probably gets more into the what has gone through it over time. What are the different adapters that are the origins of this? The different transformations, more detail about those things. Let's see. So the real distinction is that there are multiple levels by which you can start looking at how do you find out where your data has come from. What has happened to that data over time? Now, we'll get into a little bit later on why these things are important. I think that actually this slide does, and it'll probably get me out of that really quick. So if I try to do it, it goes 2 slides ahead. I'll figure this out before we're done. Well, let me first ask this. Do you understand that this is important? The data provenance is important. Understanding where your data came from, how it is transformed, etc. So why don't you just go do it? Right? That's what this slide is really saying. Well, it's a priority. People understand this. What are some of the things that are really preventing or things that you should be aware of? Obviously, the data silo issue is always something that gets talked about, particularly here. Ownership is another one that can range from fiefdoms to just real ownership issues between data. And all of these sort of battles that you get to, you can't see this data, you can't see that data, all has its own reasons for being, and very difficult to get through these sometimes. Spreadsheets is another kind of a problem with all these things, but tabular data has been around for centuries, and you're not going to get away with it. It's something that human beings really understand how to use, and so you're always going to have spreadsheets, I think, even though you're probably bringing this into more rich data stores, et cetera, along the lines, but it'll still be there as one of your main user interfaces as long as you're working in business. And then some of the unforeseen costs, well, compliance costs. How many have compliance issues that are really forcing your hand in some of these things? So this is something that it works in a lot of industries. I'll talk about financial industry some. I'll do some life sciences stuff as well. 2 areas in which these compliance issues are really large. Another organization I worked with is Procter & Gamble. And you don't realize it, but it's a chemical company. That's all they do. They do chemicals. And therefore, compliance for them is huge. All sorts of things they have to do. It's a conglomerate that happens to do a lot with chemicals. That's why P&G, I call them a chemical company. Redundant data activities. How many people have run into this sort of issue? I often don't hear this as much, but in a lot of organizations, I come in and find that, well, there's more than one. There's a bit of a question mark over the ownership, maybe, or just perhaps that there are multiple different perspectives people have been taking on the data, and therefore they have more than one project, either active or not active, going on or something. And now it becomes confusing because you have kind of 2 slight variations of your data. And then, of course, accuracy of analytics is going to be an impact here, one of your hidden or unforeseen costs, because if somewhere down the pipeline something has gone wrong with this and you're not tracking where in that pipeline things are happening, then problems can come across. And that's going to affect your accuracy of analysis. So this is kind of an interesting transition from kind of going to the high level to the next slide here, really get into provenance models. Don't be scared yet. I don't mean for you to actually read these or anything like that. I'm representing documents here and talking about how we actually go about storing provenance. We'll dig into the provenance models here a little bit, kind of pull out a little bit, and then get into a little more details a little bit later on. But the provenance storage, one of the reasons I bring this up is there's a couple of reasons for it. One of them is that if you've been familiar with and heard about the operational data hub, that this is actually what the data hub, one of the things that it does. This envelope pattern is basically saying that you have inside of your document, you have other data about the document. In this particular case, this part down here is the content of your document. And we put it in what's called an envelope, and that's one of the things the ODH does out of the box. It's a framework for really doing this kind of a pattern. But one of the others pieces of the envelope is the triples. And the reason that the data hub, and we actually adopted that in the project I was talking about, used the triples to represent provenance data is because the triples are really good at representing metadata. And one of the things they're really good about, in addition to representing the data, is representing the relationships between data. So in this case, I'm just saying that we have a document here that is pointing to some other document, has some sort of a relationship between them. And what I'll talk about as I get into the modeling next is that the good part about RDF is it really gives you a rich vocabulary that you can start talking about. Not just that there's a link between those documents, but what kind of a link there is. So these two different models here are saying basically envelope pattern in which your provenance data actually travels with your document and stays with your document at all times, versus the separate databases. Separate databases makes a lot of sense too, especially if you have a lot of provenance, because now you're really talking about two different use cases. You're talking about using your data, that's your content, versus having to look at what has happened to that data, how it's been processed, doing compliance reports, things like that. And so both of these actually make a lot of sense. It really depends on the sort of volume that you're going to see between the two, how large these documents are going to be in the end. In both of these cases, I also wanted to point out, you still have triples. These triples still can point to other documents, still have those rich relationships. Either way you're doing this. But that's just two different ways of like diving into the storage. Now, the provenance model. There's actually a couple variations of this. I'll mostly talk about the provenance ontology. Ontology in our case is nothing much more than saying, well, we're going to create a model about this data. This model happens to be object-directed, or if not really object-oriented. It basically says you have classes, you have subclasses, you have properties, things like that. That's all there really is to this model. So the main concepts in PROV-O, oh, now it's really playing with me, are entities, agents, and activities. You can think of the entities as documents. The activity is how something has happened to that document. Anything that has been applied to that document, be it a transform, be it the initial ingestion, etc. Agents can be either human or automated processes. And PROV-O is actually very good at being able to represent both of those kinds of processes. So those are the main concepts, but the key thing, as I was talking about earlier, was these relationships between them. So you can look at an entity and create a relationship. The PROV-O relationship was generated by. So this entity, this document, if you will, was generated by an activity. And that's how they kind of think of this model and this triad. An entity can also be derived from another entity. So that's basically you're changing a document, etc. Let's go one more here. And it went further. The part I really wanted to say was after this uses comes up here, we can start seeing how documents come into being. So there is some sort of an activity that generates an entity. That activity may use other entities, which may be derived from other entities. So that's kind of the core way that they start thinking about data provenance and how you're going to actually have an active processes working on that data. So, and the agent part, they've used different vocabulary for who is associated with an agent versus who is attributed to an entity. And depending on your usage, you may not need both of these. You may only need one of them. And that's actually another caution for PROV-O. It's actually a very deep model. And if you want to get into that, start small and then get bigger as you go. Because it can get very deep. Then the last part is, the last core part at least, is that you can have a time when that activity is taken. And that really makes the most sense in this case. It's not really when the document was generated, it is when the activity actually performs something. Although I think that there is a time stamp that you can also put on entities. So all of this is really a vocabulary that has been designed to describe how provenance works in your data. It's a W3C standard. As of a couple of years ago, has seen a good amount of adoption. And I think one of the things to look at, even if you're not going to go out and adopt PROV-O, is to take a look and understand the model, because people have really thought about, what does it mean to represent provenance? What sort of ways that you would think about it, and how would you create a vocabulary for it? And they've done an outstanding job, if not over job, on some of it if you get in deeper into it. And I'll talk a little bit, also I'll talk about it right now, in fact, of how to extend that and how to make it more specific to your needs. It's going to keep me on my toes, isn't it? So PROV-O XML, let's start with that one. There is an XML model of it. I'm not going to focus on it a whole lot right now. Hopefully I didn't blow my microphone out. I'm going to get my exercise too. I need my step tracker or something. So in this case, what XML is the XML part is saying that we have that's our actual entity. We have an agent and we have an activity associated with this. In this case, the agent is sales 001 and the activity is an approval activity. So we're not doing a whole lot there, but nonetheless, one of the things we're doing right away is using that vocabulary that PROV-O set up for us. We have a little bit more on this one. It's something about gene sequencing. It is an activity. It has associated with an entity that I'll call sample 4 because I'm not going to try the first name. And also an agent called Lab Technicians 32, not shown here. We also have another agent, Lab Technician FE56. So what this is telling us here is this particular gene sequencing instance was an activity that started at a particular time. There's no end time, so it might still be going on. It used sample 84. Sample 84 was actually attributed to Lab Technician 56, and it was associated with Lab Technician 32, which we, no further information at this point in time. Well, what if you really wanted to get more detailed on this? We're talking about was associated with this. I could say technician responsible for, or just responsible for maybe. It's actually just a little bit of modeling in the RDF world to extend this. All you really need to do is say that the responsible for is a subproperty of was associated with, and you actually get a couple things out of it. You get one, the ability to look at all of your responsible agents. And number two, you get ways of saying that if you had a lot of sub properties, if you will, different types of activities that you're going to be talking about, or ways that people can be associated with one of your documents, one of your entities, sequencing in this case, then you can actually go more finer granular than that, and also look at the higher level and say, show me all the associated with, now show me the more detailed ones. And this is the sort of thing that we ended up doing in the financial sector, where one of the things that they were very concerned about was the different types of adapters that they had to actually bring data in on initial ingest. And therefore we did some granular modeling on that so that they can do queries on it to say, here are what our different types of adapters are doing. Here's how we go out, find more information about each one of those. And I think another thing about this is it's object-directed. So when we say associated with lab technician G32, we then have more information about that. That can be stored anywhere in the document store, the triple store in this case. But we can have lots more information about that. It's its own representation, its own object that you can look at. So you have this ability to be able to refer to other objects that have more detailed information. All right, so operationalizing the metadata. This can be a little bit freewheeling, so I'll try to skip through some parts of it, get through them fairly quickly. I'll get to this slide throughout. Well, actually, I think I can only do it at the end now, and it'll make me go faster anyway. I want to talk about, the content, which is going to get us a little more into some of the RDF modeling, if you will. The use, how do you actually use some of this, or one of the reasons that you want to use this, and a couple of things to think about in there, and then how do you manage some of this data, and we'll talk about this. So you've heard about MIFID II if you listened to David's talk this morning. I went to another talk, and they were also talking about MIFID II. The one I actually worked with was CFTC, which is the American equivalent of MIFID. It's a regulatory body on trading. And it's similar sorts of things, not exactly. CFTC has a daily reporting requirement, whereas MIFID II has a real-time reporting requirement. So maybe not all of these things are quite the case. But the sort of thing that they're saying is that, well, this regulatory body is looking for providing more information than we normally have done. They want to do it in a shorter time frame. They actually have deadlines in which we have to actually do the reporting. And with more complexity in doing that, because the complexity, quite frankly, is where people cheat. They find the complex pieces, and that's where they cheat. So guess what? You get to now explain that complexity. Let's see. Yeah, so that's more or less the scenario. How many of you know Turtle? Okay. Then there's a quiz at the end of this. There's a syntax error. Look for the syntax error while I'm talking. So I'll talk about a couple of different ways of looking at your provenance data. Attribution is one of the things I think I've already really kind of got at. What are the processes that yielded the artifact? What are the sources that created it? What is it actually about? And this, I wanted to point out that this is a bit of the a pipelining diagram that really fits well with the ODM, operational data. I just lost that anyway. I'll get to it. Anyway, you're getting into the input, you're getting into the harmonization process, we like to call it here, because what you're really doing is taking these disparate pieces of data, harmonizing it into a single way of looking at that data. And now there's some things you could do with this. What we're saying here is along the way of doing that, we can say that this transaction was an entity. It was generated at a certain time. It's going to make me run over there. Now that I'm over here, it's going to make me run over there. I know it. It was derived from transaction A, and as I talked about before, we have some more information about transaction A, which was attributed to something called Murex, and as it turns out, Murex is a type of software agent. So even though you didn't know RDF and Turtle before this, some of you didn't at least, you now know a little bit about how to read this. You're more or less reading the names of these entities, activities, and agents, those three pieces of the provenance data model, and then a little bit of detail about each one of those. And who found the syntax error? How's it being captured? It's being captured as we go along to each one of these. And if you go back to that storage model that I started with, you're either adding it to the document when you create the document, or adding it as part of another database or another collection, etc. Yeah. So, in either one of those cases, by the way, in the case where you have it in the document or you have it as the triples, either way you can query these things as RDF triples. Sparkle is the language for that. So the very last character is the syntax error. That semicolon should be a dot. Those little things make a difference.
You're missing one entity. Transaction A is
Yeah, this should be a semicolon here. Yeah, so there's two. Yes, thank you. So yeah, so some people can't speak Turtle. And Turtle, by the way, is just one of the RDF serializations. There's also an XML version. There's a JSON version of it now. Turtle is the one that just kind of falls into triples. And I'll show a diagram here in a moment that will probably make some of these characters, if you don't know some things about RDF, it'll make things a little bit more live in terms of RDF and triples. And I'll relate it back to some of these things. So the first one was attribution. Now we're talking about evolution. How did that document change over time? So here we have trade 1, and then trade 2 was a revision of trade 1. It's as simple as mentioning that. Now you have a way of actually tracking how that, well, actually what has happened to trade 1. It was, well, trade 2 was a revision of trade 1. Actually, I think in the end of this, we did a transaction report on trade 2. Trade 2 was, again, the trade report was derived from trade 2. Given that, we can find out, oh, that's part of trade 1. If we went to the previous slide, we can find out, oh, Murex is the one that was responsible for this originally. So now we have a full data lineage there here in just a couple of slides. Yes? So what has changed from one version to another is yet another issue, and that gets into the data lineage issue. And that is something that you could also represent in RDF. Current project I'm working on now is actually doing it that way. But it goes a little bit beyond this. But one of the things you can do is basically say, what are the elements that have changed? Or if you're using JSON, what are the properties that have changed? And you'll want to do 3 use cases: new, deleted, and modified. And basically have that as part of your metadata as well. It would come in here as part of your revision of trade 1, and then you would have your changes in trade 2, saying if you had trade 2 to get to trade 1, these are the changes between the two of them. Not out of the box, no. Part of what you'd have to do is when the change is made, when you're doing a document insertion, for example, using the DLS library, the document management library, etc., add these triples onto your document as you're going on. So none of this is automatic. They're all things that you're going to have to modify and add to on top of your document. The 2 things that we've actually done here is to say we can put them into a document, and we have a model for talking about these sorts of things. Okay. Actually, there was one here first, and then.
So this assumes that trade 1 and trade 2 documents are both active in your database. So PROV-O and Bitemporal, you wouldn't use them together because trade 1 would be gone. Trade 2 would overwrite it.
Right. And so there's probably other attributes you may want to use in terms of stating that the trade has been overwritten by another one. I'm not sure what terminology you'd want to use. And I believe there is a PROV-O way for talking about whether something is current or not. The way that we actually have done this using the document management tool is basically that, well, it would actually be trade 1 in both cases, but the current version would be trade 2, and Bitemporal will do the same sort of thing. So you'll always be talking about trade 1, but the information you have in metadata is going to be different across those different versions. And so that's one of the ways that I've used this in a couple of ways. So, yeah.
I'm just thinking about applications where we have documents that change through there. If you don't do the merge or get rid of the one that's changed, so you can't keep that history just to know what you knew when.
Mm-hmm.
You may have a diagnosis that you made with only this amount of information, but the document changed.
Those are all things that you can use this metadata for. So once you have this metadata and you've stored it and you've got your generated time, et cetera, you can start doing queries across. Now there's a couple of other things that you'll probably want to look at. For example, the document management library, which does keep track of versions of documents. Also the bitemporal, and I have a slide here for bitemporal in a couple of minutes so I can explain that a little bit better. Let me, before we get into more questions, because there's lots of them, I'm going to go to the next slide, which is going to put some of this in context. It really brings in the last couple of slides together. We can now kind of see through this graphical notation, and you know, people that I work with who get into semantics always say, I want to use that language to do my stuff. Well, unfortunately, this is about the limit of what you can do with this language. You get anything more in here, the graphs become too complex to actually understand. And in fact, go onto the PROV-O website and you can see some really scary looking graphs. So, but you know, at this level, you can kind of understand it this way. After this, you probably want to start understanding one of these serializations, such as JSON or something. So you can see here that trade 2 was a revision of trade 1. We actually generated these transactions and a post-trade report that I don't think we have talked about before off of trade 2. We even have that some feedback was invalidated by the transaction report. I'm not sure what all of that's about. But we can also say that, well, where did this post-trade come from? Well, it was derived from trade 2, was a revision of trade 1. It came from Murex. Murex is a type of transaction system. It's a type of software agent. This part over here is basically some of the RDF modeling that just comes out with PROV-O. It comes with the RDF standard, RDFS, basically. This would probably be each of these is a class. Murex is a member of transaction class, therefore it's also a member of software agent. So some of these things are a little bit of modeling that we put in here. One of the other slides that I've liked to do in the past is to put up something like this and not have any of the names of the properties in there, and then put them up with the names of the properties afterwards. Having names and semantics behind your properties makes a huge difference in understanding what your data is, where it's coming from, and that's one of the real true wins for the semantics part of what MarkLogic is able to do. And also why PROV-O, the ontology modeling part of Provenance, has gotten a lot of take-up because it really gives you ways of reasoning about your data. So the next slide gets into what some were kind of getting into, and we put it in JSON this time just to show that JSON is yet another representation that we support. The bitemporal timeline is basically saying that there may be 2 dates that you're worried about every time you bring something into your system. When that event occurred, which may be outside of the system, and when the system first knew about it. So with bitemporal, the system start properties are determined by the system. You don't get to actually modify those. The other times you can say, well, this was actually occurred at 3 o'clock today. It didn't become part of my report until system you tell me when. So that's what bitemporal is all about, and that can be added on top of it. In fact, this project did do that. It used bitemporal support in addition to the provenance model to look at the data. And again, one of the things that's happening there is that as you go through that document over time, the provenance data is going to be different on each one of them because your data has changed over time, and you can look back through all of those and see those through the bitemporal or DLS. So the next bits here, now we start getting into usage. The first couple of these slides are kind of, I think, fairly normal for thinking about data governance sort of issues, where the changes to the reference data. This is always, it's easy to say this is a problem. It's a difficult thing to actually resolve. What was the state of your reference data when you actually did this transaction, et cetera. And so, it's understanding what the status of things were at that point in time. Often, compliance is one of the things that's going to push you to start answering those questions. And so that's one of the ways of looking at that. So, are rules being complied with, et cetera? Do we understand where our data has come from? But Another dimension on these, I think for data governance, you hear about these quite a bit. Another thing to really look at is a debugging tool. So we have a feed that is not doing so well. You know, it's whenever, I think the next slide talks about that sort of thing, but you know, whenever we get a high load or something like that, this feed starts to fail. And how are we going to know whether that feed is failing and whether that's the particular piece in the puzzle unless we have that metadata? Now, we may not know it in real time. It may be that we start saying, well, there's differences in our data and whatever our analysis is or something like that. And now we have to go bring that audit trail stuff up, that provenance database up, and start asking questions. Where did this come from? Where did it actually start going bad? It started with the PowerPoint slides, which this time went backwards. It's getting more random. So debugging. So what versions of the different things were causing problems? Different parts, or it could be rules, it could be transforms, etc. And then the last part is now start taking that sort of information. Now that you're actually capturing provenance data, now that you actually know something about your data and where it's come from and what could be going wrong where, you can start looking at this as a forward-looking resource to say, we actually need to look at this particular transform. You know, when it has high load rates, it tends to fail. We're having problems with that. So maybe now this becomes a planning tool as well. All this really saying that had you not gotten any of that provenance information about your data beforehand, you wouldn't be able to ask any of these questions. You have your data lake, and you have no idea how the things got into the data lake. Once you know how things got in there, you can start doing other quality assessments. And we get into, I don't want to belabor some of these things. Of course, one of the things you want to do once you have it in there, you want to be able to access this in some way, query it in some ways. And when I was kind of doing the graphing, I was kind of pointing through how you could actually walk through this. And you would do that very similarly in a Sparkle query context if you're using the PROV-O model. But certainly any kind of search querying technologies in MarkLogic can be used to basically say, now that we have that data, let's start finding out, let's get our reports, et cetera, out of those. And remember also, you know, these compliance reports that you get in life sciences and financial industries in particular, that I know of. There's probably others as well, government for sure. You know, these things are asking for kind of information that we're getting here that aren't normally associated with data. And this is really just pointing out that, yeah, all of that stuff that we had before, we're actually putting these triples, everything in documents. We're putting them in our RDF store. So all the security stuff, all the access controls, et cetera, that are in MarkLogic are still available. All that's still available. We haven't really gone beyond that. We've put all this in a bundle, and all the things that we've really changed right now is a couple of things. In our case, we're looking to the triples to actually represent the metadata. And then number two, we've used a vocabulary of how to talk about provenance, which is the PROV-O model, to say this is how we're actually going to store this data so that we can get it back later on. So getting back to those dimensions, this is that slide I showed a few slides back, in which our content is looking at the semantics and documents. We put JSON in there as well. I'm not sure why it didn't show up. And then its use, the understanding of compliance, like I say, I hear about those a lot. I don't hear so much about the debugging and forward-looking sorts of things as well. And then management, access, query, publication, and things like that. All those things that are all packaged within MarkLogic. All of these things are already inside of MarkLogic. It's a matter of doing a bit of work to basically say when I get a document, when I store a document, when I modify a document, I need to add a little bit of information about what those sources are. And so the last one is notice that it says data lineage up there. We can call it provenance. One of the ways I hear data lineage being used, though, is that this is the actual output of a provenance effort. So you can look at it that way as well. But basically what we're saying is that what MarkLogic is actually applying for you here is to say, all these things are already available. The triples are ready, the documents are ready. All you need to do is basically have a way of talking about this, the provenance of your data, and that's basically what the PROV-O model is all about. And with that, I'll take questions, because that's the end of the slides. This one here.
Have you seen examples in the financial industry where PROV-O is actually being used for data lineage of regulatory reports or something like that?
Yeah, the financial industry, one of the SWIFTs that I worked with last fall, I started out the story saying that a week before I started the job, the vice president came in and says, we should be using PROV-O. By the way, one of the reasons to use one of these common models is that it's now interoperable. In other words, your compliance organizations might eventually say, hey, you know, I've got all these crazy different ways of looking at the data coming in. I actually want to have a single way of looking at it. You know, something like this is actually, in the way they think about it, is actually something that could happen. But yes, all trades for this organization have provenance information from the very beginning. It's all in PROV-O, it's all in triples. As soon as it comes in, they're actually using the envelope pattern, so they're actually putting it inside of their document and then querying it out for their reports. They're actually using this in daily reporting right now. Okay.
If you use that envelope model, you need to preserve the changes if you're going to look back to see when you knew what when. So your merges will have to change, right? It wouldn't be that you're updating the envelope, the header becomes much bigger. It's actually a revision of that document. Is that right?
Yes. So there's a couple of different ways of doing this. I actually have not used, although this project I'm referring to had plans to use, I just mentioned it a minute ago, Bitemporal. I'll get through it. And didn't really get to that. So I can't really say, I think it will work the same way as another project I'm working with did. We're basically using the document management system, which has your latest version and then all the previous versions. Each one of those versions is going to have information about what happened to that document to get to where it is. Only that. So it's not a huge document with all of the changes, but rather over time, the different changes. Now, another way that you could do this is basically have all this information to say, here are all the things that happened to this document. You might want to use versions or something with this too, but have them dated. And then you can get back a payload that says, here are all the changes that have happened to this document. If you don't have a whole lot of changes that you expect for a document, for example, a trade has a few changes, but it's over a limited time and then it's over. Those might be, you know, the most expedient ways to actually get out that sort of information. Just give me a data timeline of all the changes in there and we'll figure it out later.
But in terms of healthcare, I'm thinking like, you know, pharmacy data is, you don't, it's richer the deeper it goes, right? So if you're tracking a patient live to know what you knew when you made those diagnoses that might have been incorrect, you kind of move on away.
Right.
From a medical perspective, not from a legal thing.
Yeah. You also get into other issues with that as well, which is, for example, your reference data. Do you use links to your reference data, or do you actually denormalize the reference data? This group that I worked with actually denormalized the reference data. In a lot of ways, that makes a lot of sense because you don't have many questions about that. You look at this particular version at a particular timeline, you have everything there.
Yeah.
Yeah.
And over 20 years or 40 years, you know, is that reference data still available? Who knows what kind of,
Yeah. Well, the other way of doing things is to have a pointer to versions of your reference data, in which case you still have a way to get to that data. You never throw that away, et cetera. But it's an extra hop. You basically denormalize after the fact in that case. And that could depend on how copious your reference data is. If it's another document in itself, that may be your most expedient way of doing it, or best performant way of doing it, I should say.
So I'm trying to think of how to do it with bitemporal, because it would be actually the previous revision. The thing is, if you're using the data hub feature, is you have no idea what the previous revision URI is, because it's actually controlled by MarkLogic once you save the new one. So does MarkLogic have a variable that you can say replace this with whatever you're going to call the document? Because I don't have control on the name of the document in temporal.
Well, with bitemporal, you have dates. You have your system date for sure.
Yeah, but in the document, but the URL is generated when you do a document temporal insert. It actually grabs the previous version, adds which is probably a timestamp, but it's a timestamp of when it does the operation, which I don't know beforehand, obviously.
Yeah. Yeah, I'd have to think more about the bitemporal piece of it, but I think that the overall vision was very much along the lines of the first part, which is the bitemporal is still storing the whole document through all the different versions. So, and therefore you can just store what the differences are as you go along, and then use dates or whatever it may be to actually.
Because if you have temporal, you actually have accessible document, you can do a diff. So as long as you know this document, the provenance was a revision of this one, you have all the information at your hand.
Okay.
I haven't figured out how to.
And that's what PROV-O can, that may be what PROV-O you'll need to do with that is basically say this document was derived from basically the previous bitemporal version or something like that. Like I said, that was one of the use cases I didn't get to, so I'd have to think through it. Well, thank you. Appreciate it.